Welcome, everyone. In this video, we're going to explore another fascinating component used quite frequently in industrial automation and robotics, the photoelectric sensor. So let's dive in right away. A photoelectric sensor is a device that detects the presence of nearby objects through changes in the light signal that it sends out into the environment. It captures these changes in light and converts them into an electrical output signal. The photoelectric sensor consists of two parts: a transmitter or an emitter, which emits light usually from a laser or a light-emitting diode, and the receiver, which receives the light and converts it into an electric signal. Receivers are usually photoconductive cells whose resistance decreases as more light hits them, or photovoltaic cells which generate voltage depending upon the intensity of light that hits them. There are typically three main types of photoelectric sensors. The first is the through-beam sensors, which have separate transmitters and receivers installed on opposite sides facing each other. The transmitter emits a beam of light, and if any object blocks this beam, the receiver detects the change. The second type are the diffuse sensors, where the transmitter and receiver are housed together, and when an object moves past the sensor, it reflects light back, letting the sensor know that something has passed through. They are the easiest to install, though they may be susceptible to dusty environments, which may reflect light back, and certain object textures, which may not reflect enough light back. The third and final one are the retroreflective sensors, which have a structure similar to diffuse sensors, in the sense that the transmitter and receiver are housed together, but they use a reflector like a mirror to bounce the light back from the transmitter to the receiver. When an object comes between the mirror and the sensor, the missing or low-intensity signal is detected and information sent back to the controller. They have higher accuracies than the diffuse sensor and are easier to install than the through-beam sensor, and thus have varied applications. They are especially useful in applications where the objects are fast-moving. Let's now look at the key specifications. The first one is the detection type, where depending upon the application, you may choose between through-beam, diffuse, or retroreflective sensors. The next parameter is the sensor range, and which, due to the way they work, is usually longer for the through-beam sensor and shorter for the diffuse sensor. Finally, the two specifications which are important for all sensors, the resolution and the response time, should always be kept in mind when selecting a sensor. The response time can especially be crucial for high-speed operations. Let's now explore a few applications of the photoelectric sensor. In manufacturing, they can be used to count the number of objects coming off a conveyor belt, ensure that no parts are missing on the conveyor belt, or to make sure that the correct order of parts are flowing on the conveyor. For example, let's say you have an automation project for a Toyota manufacturing plant, which produces Corolla, Camry, and Prius. Let's also say that the demand is 1:1:3, or out of every 5 cars, 1 should be Corolla, 1 should be Camry, and 3 should be Prius, and in that order. Since these 3 cars have different engine and body parts, photoelectric sensors placed strategically can be used to identify the height or width of these different parts and ensure that the right car is being manufactured. Similarly, in warehousing and supply chain, these sensors could be used to sort parcels, with larger parcels being moved to the left where a large robot puts them on pallets, and smaller parcels being moved to the right, where they are picked up by a smaller robot or a warehouse employee. Photoelectric sensors are also popular in non-industrial settings, with one easy-to-see example being the automatic doors in buses, metros, and elevators. And that is all for this super long video on photoelectric sensors. Hope you had fun. In the next video, we will take a look at motion sensors. See you there.